Hello, myself Sachin Gaware from RBNB College, Rampur. In today's lecture, we continue our chapter from 11th Science paper 2, that is permutation and combination. Now, in this chapter, today we see the combination when all objects are not distinct. Suppose we have given n objects, there are total n objects, and let n1, n2, n3 and so on, suppose nk are the repeated objects. That is, suppose one object n1 is repeated once, another object n2 repeats twice, another object n3 repeats thrice, and so on. Suppose the object nk repeats k times. In this n all the objects, these objects are repeated number of times. So then the arrangement of these n objects, in which these are the repetitions, this total permutation or total arrangement, which are equals to n factorial upon n1 factorial into n2 factorial and so on nk factorial. In particular, suppose we have given n objects in which A objects are repeated, B objects are repeated, means some object repeats A times, some object repeats B times, suppose some object repeats C times. Then the arrangement of all these objects is given by n factorial upon A factorial into B factorial into C factorial. This is the particular for in which three objects are repeated in A time, B times and C times. The permutation or the total number of arrangements are n factorial upon A factorial into B factorial into C factorial. Now we see some examples depending on this topic. Now we continue exercise 3.4. One of the example from exercise 5.4 is find the number of permutations of the letters in each of the following words. Now there are two words are given, one is Shantaram and next one is Bal Bharti. Now we have to find the number of arrangements of the letters from these words. Now see here in solution, suppose for number 1, for the word Shantaram, see here in Shantaram 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. Total letters are 9. Now if you observe here, all these 9 letters are not distinct or not different. In these 9 letters, some letters repeated more than one times. So here, if we observe that, starting from this A, now this A letter is repeat twice. Letter A repeat twice. Then now only letter A repeat thrice. This is 1, 2 and 3. No other letter is repeated. So the total number of, now we continue the example. So see here the example, find the number of permutations of the letters in each of the following words. First word is Shantaram and second one is Bal Bharti. Now start with first word. Now here in this word Shantaram there are total 9 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So the total letters equals to 9, and in which the letter A, see here A and A, the letter A is repeated 3 times. So here we write A repeat thrice. No other than A, there is no letter which repeats. So the total number of arrangements or the total number of permutation, number of permutations are 9 factorial upon 3 factorial. See, if we consider this formula, here in this formula, n is 9 and n1 is 3. n is 9 and n1 is 3. Okay, in this way we get the total number of permutation of the letters from the word Shantaram are 9 factorial upon 3 factorial. Now if we consider the second word, that is second one word is Bal Bharti. Now in this word Bal Bharti, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 words, or sorry 10 letters. So the total letter are 10 here. Now in this 10 letters, see here this B repeats 2 times. So we write B repeats 2 times. Then this A repeat. See here, this A repeats 2 times, so A repeats 2 times, 3 times. Here, one more A, so A repeats 3 times. Now, see here, only B and A repeats, in which B repeats 2 times and A repeats 3 times. There are total 10 letters. Now, if we consider this formula, in this formula, the value of n is 10. n1 is 2 and n2 is 3. So the total permutations or the total arrangements, total permutations equals to 10 factorial, that is n factorial upon n1, that is 2 factorial into 3 factorial. In the given formula, this is the value of n, this is n1 and this is n2, or we can say A or B. Now these are the total number of permutations from the word Bal Bharti. Okay. Now see the next example. You have 2 identical books of English, 3 identical books of Hindi and 4 identical books of mathematics. Find the number of different or distinct ways of arranging them on a shelf. Now see here, there are 2 books of English, say 2 books of English, 3 books of Hindi, 3 identical books of Hindi and 4 books of or 4 identical books of mathematics. And we have to arrange these books on a shelf. Now here the total number of books will be 9. Total books are 9. So here these are the total books, in which 2 English books are identical, 3 Hindi books are identical, 4 mathematics books are identical. It means that there are 2 identical objects, 3 identical objects and 4 identical objects. So the total arrangements or the total different arrangements equals to, so total arrangements equals to, now the total books, that is 9 factorial upon, now there are 2 identical books of English, so it is 2 factorial, 3 identical books of Hindi, so upon 3 factorial, and 4 identical books of mathematics, that is into 4 factorial. These are the total number of ways in which we can arrange these 9 books, in which 2 English, 3 Hindi and 4 mathematics identical books. Now the next example is find the number of distinct words from the letters of the word Indian. Now for this first part of this question, now in the word Indian, there are 1, 2, 3, 4, 5 and 6 letters. There are 6 letters. Now from these 6 letters, this yan repeat twice. This yan repeat twice. Yan repeats twice, and again this I also repeats twice. I also repeat twice. So directly we can say that there are 6 objects in which 2 objects repeat twice each. So the total words equals to 6 factorial upon 2 factorial into 2 factorial. This is the first part of the question, that is the total number of distinct words which are formed by using the letters of the word Indian. Now in next part of the question we ask that how many of them have 2 yans together. Now the second part, now the 2 yans are together. Now whenever we have to take the 2 yans are together, we consider these 2 yans as a one letter. So the number of words become, see here, I, D, I, A, yan and yan. If we consider these 2 yans as together, that is these 2 yans as a one letter, now here 1, 2, 3, 4 and 5, there will be 5 different letters. There are 5 total letters. Now from these 5 letters, this I repeat twice. This I repeat twice. Now here we cannot consider that is yan repeats, because we consider this yan as a one letter. We consider this yan as a one letter. So now the total letters such that yans are together, the total words in which yans are together will be 5 factorial upon 2 factorial. The total words will be 5 factorial upon 2 factorial. In this way, we can calculate the permutations or the arrangements of the objects in which all objects are not distinct, or we can say that in which some objects repeated. For which the formula is take the total arrangements, that is the arrangement of total words, that is n factorial, and divide the number of arrangements of the repeated objects. Suppose some object repeats A times, so we divide it by A factorial. Some object repeats B times, we divide it by B factorial. Some object repeats C times, then we repeat it as C factorial, and so on. In this way, we can find the arrangements or permutation of the objects in which all objects are not different. Thank you.